All right, today we're going to talk about Algebra 2 transformations. We're going to put the dilations and the translations together into one package, and we're going to graph with both things happening. So we have to remember all the things that are going to that are going to transform our functions. So first thing we should do, again, remember, is we should find the parent function of this. Always find the parent function first. That's the basic thing you should do first. So our parent function for this first one is f of x equals x squared. We know that because we have that squared. Now I need to look and see how many pieces I have that are changing this. Well, I have one on the outside there. I have two, that second piece in the inside. And my third and last piece that's being changed is on the outside there. So what are all the things that are happening? Well, first, let's do the outside piece there, that purple piece. What's happening there? Remember, it's on the outside of the parentheses. It's a multiplication. So it's on the outside of the squared. It's not affecting the squared. So it's really going to be a vertical. Now we have to think, is it greater than 1 or is it between 0 and 1? Well, it's greater than 1, so it's a vertical stretch. And it's a vertical stretch by a factor of 2. Now let's look on this part right there. This one is on the inside, so it's going to be moving it left or right. Inside moves it left or right because it's subtracting 1. We're thinking opposite, so it's going to move it right 1. And our last piece, it's on the outside, it's plus 1. So it's on the outside, that means it's going to move it up or down. And since it's positive, it's going to move it up 1. So three things are happening in this function, in this problem, in this transformation here. So now we need to fill in our table with our parent function values, remembering our x's and our y's that we normally put in there. And let's think about what changes what. Which things change our x's, which things change our y's. I'm going to circle the things that change my y's. I'm going to circle those, and I'm going to star the things that change my x's. And I'm going to look at vertical stretch. It's on the outside of the parentheses. Well, if it's on the outside of the parentheses, it's going to change my y's. Did I say I was going to circle my y's? This is going to change my y's. The green, that's going to be another y. And the only thing that's going to change my x's are right there, my right one. So I'm going to go to my x values right now. And since I know I'm going right one, I'm going to add 1 to each of these. So it's going to be negative 1, 0, 1, whoops, I forgot 1. Yep, 2, 3. So that's going to be my new x values right there. Those are my new x values. Now we're going to go, and it doesn't matter which one you do first, but you need to do two things to your y values. So vertical stretch, it's a vertical stretch, and it's by a factor of 2, so I'm going to multiply by 2 first. So I'm going to get 8, 2, 0, 2, 8. And then we're also going to move up 1. So I'm going to really add 1 to each value too as well. So we're going to get 9, 3, 1, 3, 9. Now these are my new y values. So my x and my y values are here, negative 1, 9, 0, 3, 1, 1, 2, 3, 3, 9. And I'm going to graph each of those points right now. So after you graph each point, you guys can see that it does look like it's been stretched. It's been stretched out a little bit. It's moved to the right 1, and it's moved up 1. So that's all the things that happen. Three things have happened in that problem. Let's try another one. First, what is my parent function? Again, my parent on this one is f of x equals x squared. How many different things are happening here? Well, the first thing I notice is that 2 there. And the second thing I notice is that minus 1. All right, that 2, it's a multiplication one, right? And it's inside of the squared. Notice these are the parentheses for the squared. It's inside of the squared, so I know it's a horizontal. And since it's greater than 1, it's going to be a horizontal shrink, which means I'm going to be dividing. And that minus 1 is also on the inside, so that means I know I'm going to be going left or right. And since it's opposite, I'm going to be going right 1. Now again, we're going to go look at our table, fill that in with our parent function, and I'm going to go look and see what happens to these. Horizontal shrink, that's on the inside, so that's going to change my x's. Right 1, that's again on the inside, so that's going to change my x's. So both of these are going to change my x's, and I'm going to go opposite of what I would think. So first thing I'm going to do is I'm going to, I'm going to half them all. So opposite, so we need to divide by 2 since there's a 2 on there. So I'm going to divide each piece by 2. This is going to be negative 1, negative 1 half, 0, 1/2, and 1. Those are my new x's there. But then I also need to move right 1, which when we're moving right, we're adding 1. So really this is going to become 0, positive 1/2, 1, 1.5, and 2. Here's my new x values. Here's my y values. Now me personally, I don't want to graph a half point there, so I'm going to change my y or my x values. What I'm going to go by is I'm going to go by halves. So it's going to be -1, -2, 1, 2. Now I'm going to graph those and I'll put it up here for you guys to check. And there's what my graph's going to look like. Now I know what you guys are thinking, that the horizontal shrink that happened, you can't really notice it because of the change in scale. But let me show you guys what it would look like without changing that, or without having that horizontal shrink there. I'll show you once. So in the red there, I have what the parent function would look like if I moved it to the right one place. And you guys can see that it definitely is shrunk. The x's are shrinking together, getting closer together. All right, let's look at this problem and see what's happening here. So I'm going to point arrows to all of the things that I notice that are happening. And you notice there's 4 things that are happening in this problem. What's my parent function? My parent is f of x equals the absolute value of x. There's my parent function. So let's look at each of these pieces. First thing I notice is that negative. That means we're going to reflect over the x-axis. Negative on the outside of that absolute value. Next thing I notice is that 2, and that's on the outside again, so that's going to be a vertical. And because it's greater than 1, it's going to be a stretch. We have a +3 there. So that +3 on the inside, that means that we are going to move to the left 3 places. And the last thing that we have is the -4. And again, that -4 is on the outside. So we know we're going to move down 4 places. All right, so now again, I'm going to go circle, star, etc., etc. I'm going to circle the ones that affect the y's. That means the stuff that's on the outside. This is going to affect the y, this is going to affect the y, and this is going to affect the y. So we only have one thing affecting the x values. So let's fill in our normal x's that we have, that we use for this parent function. All right, so the first thing I'm going to do is I'm going to do what happens to my x's, because only one thing happens to my x's. And since we're moving left, and we know left is minus, we're going to subtract 3 from each piece here. So really it's going to become -5, -4, -3, -2, -1. There are our new x values. Now we're going to change our y, and we're going to have to change our y 3 times. It doesn't really matter which one you choose to do first. So I'm just going to go from top to bottom. So first thing I'm going to do is I'm going to reflect over the x-axis. When I reflect over the x-axis, that means that I need to multiply by -1. So I'm going to multiply by -1 here. So we're going to get -2, -1, 0, -1, -2. All right, next thing I'm going to do is I'm going to vertically stretch by 2, a factor of 2, which means I need to multiply by 2. Which means I'm going to take this and make it -4, -2, 0, -2, -4. Now I know what you guys are thinking, couldn't I just multiply by -2? Absolutely you could. If you want to do that step in one fluent motion, absolutely multiply by -2, that'd be fine. I'm just showing every single step for this video. So now down 4, so we're going to go -4. So again, we're going to subtract 4 from each piece here. Now we have our new y values. So here are our x and our y values. Now do you have to show every single step when you're doing this? No. I choose to do it this way because I think it helps out and makes things nicer. It makes things easier to see what's happening. So I'm going to graph each of these pieces here, and we'll get. All right, and here's what the graph's going to look like. Notice that I use the orange and the pinkish one to be the x and the y's. The outside pieces are the ones that are your new x and your new y's. All right, I'm going to do one more problem for you guys here. You can look at this one and see it's a little bit more difficult. Our parent function, first things first, our parent function is f of x equals the cube root of x. We know that because we have the cube root in there. So now let's underline first I'm going to start with the things that are the x values. Our x, these are going to affect our x's. So our normal parent x's are -8, -1, 0, 1, and 8. So what I'm going to look at first here is I want to think about, well, which one should I do first? And for this, when we're inside, we have to think opposite of the order of operations. So you guys would instinctively think that we should do this piece first. But really, we need to do this plus one part first. And since on the inside, we have to think opposite. So we're going to subtract 1 from each of our x values. So -9, -2, -1, 0, 7. Now we're going to do our multiplication piece. So kind of like we're unraveling the inside here. But since it's on the inside again, we're going to do the opposite, which really means we're going to multiply by 2. And really what's happening to our graph, remember, is we're having a horizontal stretch by a factor of 2. So really it's going to be -18, -4, -2, 0, and 14. All right, now the y's are a little bit easier because we can actually just go in the order of operations here. So our y values, remember our parent function y's are -2, -1, 0, 1, 2. And now we're going to multiply first. So we're going to multiply here, and we do multiply by 2 because it is on the outside. We do what's on the outside. So -4, -2, 0, 2, 4. Last but not least, we're going to subtract by 3. So we're going to get -7, -5, -3, 5, sorry, not 5, -1, -1, and 1. All right, let's graph this bad boy here. So I'm going to show over here my table. This got a little messed up here, x and y. My new x's are -18, -4, -2, 0, 14. Notice I just took these pieces over there. My y values are going to be -7, -5, -3, -1, and 1. Again, we're taking our pieces from over here and we're putting them over, so our far right piece. Now since I have some pretty big numbers in my x values, I'm going to graph my x's using 2. So I'm going to go by 2's on my x values. All right, so you guys can see from my graph here that a lot of things have changed from my basic, my standard, the cube root of x. It looks a lot different. It's definitely been affected. It's been stretched, it's been shrunk. Well, actually, it's been stretched both horizontally and vertically. It's been moved left 1, it's been moved down 3. So that's all I'm going to do for examples for you guys. Let me know if you guys have questions. Make sure you guys watch the next videos, which are talking more about transformations.